Hello everyone. Today we will learn about cleaning equipment components and maintaining machinery. Let's start with a question. Why does a machine tool that hasn't been cleaned for a long time experience reduced machining accuracy or even malfunctions? The answer may lie in the oil stains, rust, or lack of maintenance on the components. For example, a factory once suffered equipment jamming due to carbon buildup on the guide rails, resulting in direct losses of hundreds of thousands of yuan. This shows that proper cleaning and maintenance are fundamental to efficient equipment operation and longevity. Next, we'll dive into the related knowledge. In this lesson, we will study how to clean mechanical components and how to maintain electromechanical equipment. After completing this lesson, you should achieve the following objectives. 1. Master the methods of cleaning components, including degreasing and rust removal. 2. Understand the importance of maintenance and become familiar with daily, first-level, and long-term maintenance practices. 3. Learn the sequence and precautions for cleaning components. Let's begin with component cleaning. Cleaning components is crucial as it affects both assembly speed and quality. Cleaning includes removing oil stains, scale, carbon buildup, rust, and old coatings. This course focuses on degreasing and rust removal. Degreasing removes oil from parts using cleaning agents like organic solvents, inorganic solvents, or surfactant-based metal cleaners. Cleaning methods include wiping, soaking, spraying, vapor cleaning, and ultrasonic cleaning. There are manual and mechanical cleaning approaches. Organic solvents include gasoline, diesel, and kerosene. Oil washing is convenient and effective in degreasing and non-corrosive to metal. However, oil-based cleaners are costly, unsafe, and environmentally harmful. With growing energy concerns, their use has been limited. Inorganic solvents include alkaline solutions. In the past, many parts were cleaned with alkaline solutions, typically heated to 80 to 90 degrees Celsius. Alkaline solutions have strong degreasing power and are more cost-effective than surfactant-based cleaners. However, they are highly corrosive to the surface of components, especially for non-metallic and non-ferrous materials. So they should not be used on rubber, plastic, or aluminum alloys. Additionally, alkaline solutions can irritate the skin. Surfactant-based metal cleaning agents, commonly referred to as metal cleaners. They have good cleaning power, provide some corrosion and rust protection, and some specialized cleaners can replace gasoline or kerosene in process cleaning. They are non-irritating, non-flammable, and non-explosive, improving working conditions and safety. Using water-based metal cleaners instead of oil-based ones saves energy and significantly reduces costs. As the chemical industry develops, raw material costs for these cleaners are decreasing while quality improves, leading to more widespread application. Manual oil removal typically uses a wiping method. Parts are placed in a container with kerosene, light diesel, or a chemical cleaner and wiped with cotton or brush to remove the oil stains on the surface of the parts. This method is easy and low cost, but labor-intensive and inefficient. It is mainly used for degreasing small to medium parts or the working surfaces of large parts in small batch production. It cleans thoroughly with few blind spots, something mechanical methods can't always achieve. Gasoline is generally not recommended as a cleaner. It dissolves fats aggressively, harms skin, and poses a fire hazard. Mechanical degreasing uses dedicated cleaning machines with high automation and efficiency. These machines come in 3 types: soaking, spraying, and combined soak spray. Soaking cleans well, but is inefficient and labor-intensive, so it's rarely used now. Spraying uses pressurized, heated cleaning liquid to remove grease from the surface. This method is effective, productive, and easy to automate, making it widely used. However, the equipment is complex and best suited for parts with simpler shapes and heavy surface grease. Spraying can still leave some blind spots uncleaned. To solve this, combined soak spray cleaning machines have been developed. Ultrasonic cleaning is ideal for precision parts like small bearings and valve cores. When degreasing using these methods, proper cleaning agent selection is key. Use different cleaners depending on the material of the parts and the type of lubricant. Vegetable and animal oils can be removed using alkali solutions. However, alkalis corrode metals to varying degrees, especially aluminum. Mineral oils don't dissolve in alkaline solutions. When cleaning the mineral oil stains on the surface of the parts, it requires emulsifiers to form emulsions for cleaning. Heating, agitation, pressure spraying, or ultrasonic assistance can accelerate the process. When cleaning parts, attention should be paid to the sequence of cleaning. In general, precision parts, for example, lead screws, should be cleaned before regular parts. Clean internal areas first, followed by the exterior. When using oil or an oil bath for cleaning, replace the oil promptly if it becomes too dirty. During the assembly and adjustment of electromechanical equipment, thorough rust removal from parts is essential for quality assurance. The following several methods are usually used to remove rust. Mechanical rust removal. Mechanical rust removal uses friction or cutting to eliminate rust. Common methods: brushing, grinding, polishing, sandblasting. For single-piece or small batch production or repair, rust on the surface can be manually ground off. In mass production or under suitable conditions, mechanical rust removal can be used, such as electric grinding, polishing, or burnishing. Sandblasting removes rust using compressed air to spray sand of a certain grain size onto the rusted surface of parts. This method not only removes rust quickly, but also prepares the surface for subsequent processes such as painting, spraying, or electroplating. After sandblasting, the surface becomes clean and gains a certain level of roughness, which enhances the adhesion of the coating layer to the part. Chemical rust removal uses acidic solutions to dissolve the oxides on the metal surface, thereby removing rust. The typical process includes degreasing, water rinse, rust removal, water rinse, neutralization, water rinse, dehydrogenation. To ensure good rust removal results, the solution is usually heated to a specific temperature. Time must be strictly controlled. The chemical formula should be selected according to the material of the part being treated. Electrochemistry rust removal, also known as electrolytic corrosion. This method is highly efficient and provides high-quality rust removal, but it consumes a lot of energy and requires complex equipment. Common methods include anode and cathode corrosion. The main disadvantage of anode corrosion is that when current is too high, over-corrosion may occur, damaging the surface. Suitable for parts with simple shapes. Cathode corrosion does not cause over-corrosion, but hydrogen can penetrate the metal and cause hydrogen embrittlement, reducing the part's ductility. Previously, we learned about parts cleaning. Next, we will study the maintenance of electromechanical equipment. As shown in the diagram, the goal of three-level maintenance is to ensure efficient operation, extend equipment life, and reduce failures through inspections and care at different levels. Daily maintenance. First-level maintenance focus on surface cleaning and basic inspections, performed by the operator at the end of each workday. Periodic maintenance. Second-level maintenance regularly lubricate the equipment, conduct functional checks, etc. Check the wear condition of the transmission system, replace key wear parts, tighten mechanical components, and adjust parameters. Operator-led, with technician assistance, carried out weekly or monthly. Long-term maintenance. Third-level maintenance comprehensive inspections, replacement of heavily worn components. Precision calibration, for example, machining accuracy of machines, measuring equipment precision, upgrades of control systems. Meanwhile, update or upgrade the control system of the equipment to enhance its performance and reliability. Carried out mainly by professional technicians quarterly or semi-annually. Daily maintenance serves as the foundation, focusing on equipment cleaning and basic inspections, providing essential support for normal operation. Periodic maintenance further maintains equipment performance through lubrication, functional checks, and timely detection and resolution of issues, acting as a strong safeguard for stable equipment operation. Long-term maintenance involves in-depth care, such as comprehensive inspections, replacement of worn parts, and precision adjustments. It aims to restore and enhance equipment performance, ensuring stable operation over the long term. These three levels of maintenance work in coordination, complementing each other to ensure appropriate care at each stage of equipment use. This effectively extends the equipment's service life, reduces failure rates, and ensures continuity and stability in production activities. Through today's study, we have gained a basic understanding of cleaning mechanical and electrical equipment components and performing equipment maintenance. You need to master the methods of component cleaning, including degreasing and rust removal. Understand the importance of the three-level maintenance strategy for electromechanical equipment. Become familiar with the contents of daily, periodic, and long-term maintenance. This knowledge will lay a solid foundation for your future studies and work. Finally, please review this lesson and complete the following exercises to reinforce and deepen your understanding. That's the end of today's lesson. See you in the next class.